So this is the fix of the Naviter Oudie. I'm gonna just kind of do some voiceover here as I kind of fast forward through the fix, but there's some points to note as we put shielding on this cable. I apologize for the kind of junky blurred out stuff. I'm trying to block out poor Britton's personal information that he decided to plaster all over the device. It really makes it hard to make YouTube videos when somebody puts their name all over everything. I guess I could have just left it, and then Britton could have gotten all kinds of fun phone numbers about, hey, can you fix this for me? That would have been interesting, and I'm sure he would have loved that. As we get in here, when you start to open this up, make sure that you don't just start pulling things apart. These cables are very tightly pulled across. If you just open this up in a hurry and rip it apart, you're going to end up breaking all these cables, and they're quite delicate. So you've got to open it just a little bit and go in there and actually disconnect those cables first. When you go to disconnect that big ribbon cable from the board, there's a little plastic tab that flips up and then the ribbon cable slides out. For the other one, just pull it up slightly from the board. Something plastic and not too harsh should be good to pull that up with. The battery is kind of stuck down with just Velcro. You can pull up on it pretty nicely and it'll just come free. It's not really a big issue. Once you get that other power board out of there, you can take these little screws out all the way around. It's a real small little Phillips. I think it's a double or a triple-aught Phillips. Be careful with those screws. They're just into plastic. You don't want to damage them. If you work this knot forward a little bit and kind of pull it out of the way, you can get to that fourth screw. You can push the screen up from the front, and then it'll slide out of the other latches. So that whole ribbon cable assembly is the problem area. That's where all of our noise is coming from. So essentially what we're going to do here is just take some copper foil tape and try to shield the entire thing. The next little bit is just kind of trying to figure out how few pieces of copper foil tape you can use to suitably shield it all. And we're going to want to get a good bit of overlap, basically as much as we can get overlap on the front without being in the visible area of the screen. You'll see the way that I do that is I actually leave a little bit of extra and then I just carefully kind of cut the excess away. If you do go the way that I'm going, be very, very careful. I'm using the X-Acto knife here in a second with a straight edge. I'm just scoring the copper. I'm not even actually cutting into it. You want to be very careful that you don't damage the screen or the touch sensor overlay. From there, just some kind of clever and creative cutting of the foil will get it to fold over nicely. You want to try to create as few of these little foldovers as possible. Obviously, there's going to be several in multiple different places, but try to minimize it as best you can. Keep in mind at the end, you can't just rely on the foil contact because of the adhesive, so we're going to have to actually solder all these joints. You'll see that here in a minute, but the point is the nicer you are through this phase and laying things out and making it easier on yourself later, the less you'll have to go back and solder. I suppose if you have access to a wider piece of copper foil tape, you can probably do this all in one pass. I didn't have it, so I just kind of used what I had laying around. It doesn't much matter as far as what tape you use or anything like that. It's just copper foil tape. Different ones have better and worse adhesives. For what we're doing here, it doesn't really matter. The most important thing to note is that the copper itself isn't going to necessarily conduct. You can't rely on it just because of the way the adhesive gets in the way of the conduction. So that soldering step that we're going to get to is quite important. This, aside from just kind of mending the corner here, which is what I'm doing a little bit off screen, I apologize for getting out of the camera. The next thing we're going to do is lay down a big flat piece of copper across the back. Now, this seems like it's doing nothing, but it's actually the whole reason this works. We can't solder that copper foil tape to that back plane because the back plane itself is stainless, and it would just kind of be a mess. You'd have to use silver solder and lots of heat, and you'd end up damaging the screen. So what we're actually doing is utilizing this big plane of copper foil tape as capacitive coupling. So because you have the conductor surface of that steel plate, which is grounded to the screen's logic ground, and then we have this big flat plate of copper over the top, we're creating a capacitive coupling. At the frequencies that we're dealing with at that 100 megahertz region where we're having, or 150 I guess, where we're having radio noise, this capacitive coupling is enough to effectively conduct it for AC. So even though they're not actually soldered together, that big flat area is what allows the RF signals to be dissipated in that backplane, or essentially to allow our shield to be grounded. You'll notice here that I've just kind of laid some flux down ahead of time, and now I'm running back over all the flux with a soldering iron and some solder. The one thing you want to do is be very, very careful with the amount of heat you let get on that ribbon cable. The ribbon cables are quite touchy, and although they're heat resistant, they're not necessarily heat proof, and if you get too wild with a soldering iron, you're going to damage it. The iron I'm using here is a Metcal iron that keeps the tip at a pretty constant temperature, and it's a relatively low temperature tip, so I'm able to not worry so much about burning it. If you have an iron that's not so good about temperature control, perhaps just put dots all the way along. You can kind of stitch it with little dots, but just put a dot down, let it cool, and put another little dot down. I apologize for the lighting here. I'm kind of inspecting all my work with a microscope, and the microscope's light is not exactly great for the camera. So at this point we need to shield where this connector is on the front and the back. I'm going to lay down some Kapton tape here first just to insulate. What we're trying to avoid, and the reason I'm putting this down, is to keep our copper foil shielding tape from shorting things out on the board. So I put down a piece of Kapton tape, which is just an insulative tape, and I put that down in a larger area than what I intend to put the copper foil down. This just adds a layer of resistance so that I don't short anything out. This next little piece of copper foil tape here is it's probably not necessary. The circuit board itself should have a ground plane that should be well via stitched, and that should create a situation where there's an inherent shielding in the board itself. While we're in this thing, it makes a lot of sense to just go ahead and I guess excess shield it, and just in case the ground plane on the circuit board isn't enough. So I've laid that extra piece down, and it's just capacitively coupled to that other shield as well, so nothing really too magical there. Here I'm just taking a bit of alcohol and a paper towel to get the flux residue off. Be careful as you lay the screen back in. Obviously the flexible ribbon cable is flexible, but you can still tear it and break it, and you want to avoid flexing it any more than necessary. So kind of do the minimum you can get away with and get this device put back together. Again, with these screws, when you put them back in, the plastic that they're going to, and I guess that's with all the screws on the Oudie really, the plastic that they've used for their enclosure is quite soft, so just be careful not to strip these out when you put them in. You don't need a lot of force here, just enough to hold the screen down. And actually the soft plastic acts kind of like a thread locker, so they're not going to come loose on you. So just put it down enough that that screen's not wobbly in there, and you're good. There, the camera cut out, so I skipped a little bit, but all I've done in between those two frames is connected that ribbon cable back to the board. Just be gentle with it when you insert it. I'm now cutting an extra little piece to cover the connector itself. One of the spots that we were radiating quite a bit of of RF power was out of that connector itself. So this piece of copper foil tape over the connector does a good job of just sealing that off. This is a little less than ideal because now you've got copper tape in the way if you choose to take this device back apart. I'm not super worried about it, and part of the way that I've done this is I've extended the copper tape wider and I've put just a tiny bit of solder on the edges. This will just tear away if you start to open this device up in a hurry. It'll just kind of rip. It would create a little bit of cleanup, and you're going to have to go peel some old tape back off after you've opened this device back up, but that's not that big of a deal. And again, you're not really opening and closing this device all the time, so we're going to call that good enough. Here it's a little tricky to work with. You might want to prop this device up on something. I'm kind of holding it vertically and soldering down in it, but again, you can't have that thing all the way open. Also, I guess in hindsight, putting that battery in before I put that shielding tape on the ribbon cable probably would have been a little easier. It works out fine here, but inserting that battery beforehand would have been easier. Make sure you don't forget to connect that other little connector to the ribbon cable, and other than that, you should have killed the radio noise.